Okay, so today we start looking at a Vernier calipers there. That is a part that is extracted from the Vernier calipers there. The Vernier calipers mostly, and a very example, it can be something that has got something like this, and then we've got something like this, okay. Then after that, then I've got a section part which is there, something like that. That is the diagram for a Vernier. And then there's what we call the inside, which is the inside jaws, which is these ones here. These are the inside jaws. These inside jaws, they measure something which is where inside measurements. While these ones here are what? Outside what? Jaws. What do outside jaws measure? They measure what is where? Outside what? Measurement. And then there is what you call the main scale here, if you can check. So in short, and then the down part there is what you call the Vernier what? The Vernier scale. There's a Vernier scale which is down here. So if we have got something like this, and then we've got the main scale which is here, and there's the Vernier scale which is down there. So now, when it comes to a Vernier calipers, what does a Vernier calipers measure? According to what you have written there on the diagram, there was saying that a Vernier calipers measures the length of very short objects, such as the diameter of what? A coin. So diameter of a what? A coin. The same way the coin is like this, we can measure the diameter of this coin by using a what? A Vernier what? Calipers. Apart from that, we can measure sometimes the inside, the external and internal diameter of objects such as a what? A pipe. Pipe, this is a pipe like that. So we can measure the diameter of this pipe, meaning that I can measure out either the outside part using the what? The outside what? Jaws. I can measure what is inside using the what? The inside what? Jaws. So Vernier calipers measures a very short length of maybe objects such as the diameter of what? A coin there. Now, when you're carrying out the reading there of the Vernier calipers there is the main scale. So in here we have got, this is the main scale. This is the main scale, and then now this is the what? The Vernier scale there. And the mark of precision that we use in the Vernier calipers, according to what we said, is 0.1, which is in what? Millimeters, up to somewhere 0.02 millimeters. But so the mark of precision for a Vernier, mark of precision is what? 0.1 what? Millimeters. Take note of this. This is very important, which is the mark of precision. And that mark of precision, mostly we multiply it with the what? With a Vernier reading there. Now, how can you come up with the reading? Find the reading, okay? Let's go to the reading there. Okay, let me erase this part here. Let's come to the reading. The first thing, when you're finding out the reading there, you first start with the what? The main reading from the main what? Main scale. This is the main scale and this is the Vernier. So main scale reading. Okay, so let's say main scale what? Reading. So what is the main scale reading there? Okay, we come here. Before this comes, we are looking at this mark here. You always get the main scale reading, a mark before the Vernier reading comes down here. So it means that we're counting 3. This is 3 point what? 3.1. 3 point what? 3 point what? 3. So we're ending here for the main reading before this comes here. So you get the mark before the Vernier. So the main reading or the main scale there, the main scale reading is what? 3 point what? 3.3 there. Okay, so 3.3 before this one. Then for this one here, how do you get the reading? You get the reading where it is coinciding, protruding mark. That is what we call coinciding mark, where pamwamba na pansi they are in the same line like that. So you can count 0. This is what? 1, 2, 3, 4, at what? 5. 5, that is where there is a coinciding mark. This is where you end. Pamene kapitira pamwamba na pansi, pamene trim straight line. So the Vernier. So we come to the Vernier. Vernier what? Reading. The Vernier reading there I was saying is what? 5. Now we multiply this 5 by the mark of precision. What did I say about the mark of precision? Mark of precision for this is what? 0.1. So which means when you multiply 5 times 0.1, you get what? 0.5. Now to get the reading now, you are going to add now. So the reading now is equal to what? 3.3 plus the Vernier reading, which is what? 0.5, which will give us what? If you add, which is 3.3 and 0.5, you get about what? 8, then what? 3. Tevyo, which is 3.8 there, which is the millimeters. Then that is the reading. That's how you get the reading.
So 0.1 is mandatory.
Yes, it's a mark of precision there. Yes, it's a mark of precision. It's a mark of precision there. It is mandatory there, but you always multiply the Vernier reading with 0.5 and not the other reading there. Let's check the other one there, the second one there. Okay, just run out of chokes up, huh? That one, I think. Okay. Now let's look at the second one. The second one again, we get the reading here before this reading comes now. So let's say the main what? The main reading. The main scale what? Reading. Main scale reading. Okay? The main scale reading there is equal to what? We are getting this part here, which before this comes in. And what is this mark here? What can you say?
0.2.
0.2. Have you seen? This is 2. 2.1, 2.3, 2.4, 2.5, 2.5, 2.6, 0.7, 0.8, 0.9, then what? 3. Now we are looking at the, so we can start going backwards so that we can know. If this is 2, what is this mark here first? 1.9. Nada. Why you want to touch up? 1. In 2. So in 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, then what? 3. But me, I'm looking for the mark which is here. So that means that it's behind. So no, not 1.2. Look at this. If this is 2, what is this? 1.9. Natasha, Natasha? Yes. In 1.9. If this is 1.9, this is what? 2. 2.1, 2.2, 2.3, 0.4, 0.5, 0.6, 0.7, 0.8, 2.9. Then what? 3. So in 1.9. I'm interested in before ACA. If this is 1.9, this is 1.8. Very good. So now this is 1.8. Come in, Nelly. Come in. So this is now 1.8. So the mark that I'm interested in is what? 1.8 before this comes in. Money. Why you want to manager? That is how what they do, guys. They want to confuse you. So they want to indicate. You start going backwards much. So that we know the mark which is it. So I'm now interested in the 1.8 here. Nelly, you read this? You did not, you have found this. Found us there. Continue. So this is our 1.8. So I'll say 1.8. You go to the what? To the Vernier reading. Vernier reading is equal to what? You check now. 0, 1, 2, 3, 4, 5, 6. What is there? 7. So it is 7. So we write 7. But we multiply this 7 by what? 0.1, which will give us 0.7. Now let's add now. So the reading now, therefore, okay, reading is equal to what? 1.8 plus 0.7. And what are you getting? So if you what? 2.5. So we have 2.5 what? Millimeters. This is the answer. Exam, very important. Yeah. Very important. Sometimes they even bring a question, a Vernier caliper they bring, and they also bring maybe you converting that, changing that, the answer that you found in 2 centimeters. After you convert it in 2 centimeters, you change it much into maybe standard form. I think I'll give you a question like that. It comes like that. So this is what you do. The first thing, main scale reading.
There, but the funny thing, you just start as 1.
This 2, when I'm going this side, yes, this is 2.1. 2.2. If this is 0, then up in 1. Then 10 in yes. Sometimes you find that they won't even put a line like that. Sometimes even color so it's okay. In Japan 0, 1, 2, 3, 4 like that. They will just write 0 so for you. Then a 10 so. Let's look at the last one. We start with the what? The main reading, or the main scale reading if you want. Main scale reading. Okay? Our main scale reading there, let's check. Before this comes in, the mark is where? Here. Tell you, if this is 1, this is 1 point what? This is 1 point what? 2. So we end here on 1.2 before this comes in. So we have 1.2. Then we come to the what? The Vernier. The Vernier what? Reading, or the Vernier scale readings, okay? Is equal to what? You check where it is coinciding. Pamene kapitilira pamwamba na pansi. 0, 1, 2, 3. Kapitilira papa 3. 3. So I'll go and write 3. But I'll multiply this 3 by what? 0.1, which will be 0.3. Therefore, my reading manje will become, my reading is equal to what? The main reading, which is 1.2 plus 0.3, which I'll get now what? Which is 1.5 millimeters. So sometimes you can even tell to say, can you convert this? Maybe, can you convert this in what? Centimeters. How do you convert? 1 centimeter is equivalent to what? 10 what? Millimeters. Like that. So if I'm changing, I'll put 1.5 under millimeters, and then I'll put, do you know how many centimeters are in 1.5 millimeters? No. You put what there? X. When I cross multiply there, I'm going to get, I'll write it just here, 10 what? 10x is equal to what? 1.5. Then I'll divide by what? 10. I also divide by what? 10. So that our x is equal to what? Now, it means that here we'll start dividing now. 10 into 1, it cannot. Or maybe the best way, if you divide by what are you getting? 1.5 divided by 10. So 0.15. Now this one changes now to what? Centimeters. Now if you're told to convert this now into standard form, this point is moving how many times? 1 time there. 1. So in short it will be 1.5 times 10 to the power, when you're going this side is by what? -1, which is now what? Centimeter. This is under standard forms. So sometimes they can tell you to say, after finding that answer, convert it into what? Centimeters. This is how you convert into centimeters. Like that. Ha. Hey, Nelly, you learned about my conversion, even my standard form, unless maybe Natasha. A standard form. So this is what you do, but I'll just show you, but I'll give you a question. I think that was an exam question where you're supposed to convert from the millimeters that you have found as the answer, convert it into what now? Centimeters. After converting it into centimeters, they even ask you how many significant figures are there. They will ask you, even here, how many significant figures are there? There are 2 significant figures there, which is 1 and what? 5. I think we did. How many significant figures are here? Only 1, which is what? 3. The 0 is not a significant. If the number starts with my 0 point, I think if Vernier, I think you remember where we learned. Zeros after a number, for example, when you've got 400, how many significant figures are there? 1. But if you've got 400 and maybe 3, how many significant figures? 4. All of them now. So zeros between a number are what? Significant. Then in a decimal number, manje, if you have got 0.003, how many significant figures? 1. But if you have got 0.0030, how many significant figures? 2, manje. It means that the zeros now becomes. But if it is 2,000, how many significant figures? 1. But if it is 2.000, how many significant figures? 4. All of them. Because of what? The decimal point. Yes, but if there is no decimal point, it means that the number of significant figures here is 1. I think it's only you, Natasha, but Nelly, I think, learned. I think we find time. Yes. No, it means that there is error there. You only get when there is a coinciding. When there is a coinciding mark here, so if there is no coinciding mark, it means that there is no measurement there. There's no way you can carry out the measurement if there's no coinciding. But there must always be a coinciding mark there where you're supposed to end.
So, I do a question which comes like you exceed your coinciding mark there in the
No. This is the Vernier. Yes, Kai. When you are using that mark there, there are marks that are like that. They are swapping each other in short like that. So it means that while you're going to have the reading, while you're going to have an object tied started there again, if you are getting maybe the measurement of a coin, so the diameter of this coin here, why it is going to be tight, it means there will be some marks that are going to coincide, and you check from there. Yes, there will always be a coinciding mark there. Okay, so we can write there, and then there are some questions there, then we'll use some exam questions from there. We're okay? Yes, okay.